right, let's take a look at page 2 of the CFU from 1.4. The key thing here now is on the back page, we're going to take a look at doing stem plots or stem and leaf plots as another way to represent quantitative data. So in question number 3 here, it's called shopping spree. It says a market consultant observed 50 consecutive shoppers at a supermarket. One variable interest was how much each shopper spent in the store. Here is the data in dollars arranged in increasing order, which is very nice. It'll make doing some of this a little bit easier. So, in question A, it says round each amount to the nearest dollar, then make a stem plot using tens of dollars as the stems and dollars as the leaves. Now, one of the things is when you're given data like this and doing a stem and leaf, it's very smart to actually do that rounding part. So what we're basically saying here is this is $3 and $9 and this is $9 and this is 11 and so forth. So we're doing that for all 50 data points. So now you want to make a stem and leaf plot. Okay? So to do this, okay, so the first thing I'm going to do is I'm just going to title money spent at the supermarket. Okay. Now remember in part A at least here, and the reason why I'm doing this is, or it's laid out this way is so that you have space to do both of these graphs. Okay, so they ask you for the stem plot, okay, to use tens of dollars as the stem, okay, and then the leaves are just the single dollars or the ones. Well, since the first couple data points are $3, $8, and $9, there is no tens digit, so we just assume it's 0. So we have, the single digits, the tens, the 20s, and the 30s, and the 40s, and the 50s, and the $60, and $70, and $80, and $90 range. Okay? So what I also want to do is make a little key here to help us represent what the values mean. So I'm just going to put a 2/ with a 0 here that represent $20 spent on groceries. Oops, that's funny, YS. You can tell why I'm a math teacher. Should be IES, right? All right, groceries. I'm sure you'll probably see me misspell about 20 words in these videos. Anyway, off task. So again, what I'm going to do is I'm going to, again, look at these values rounded and start putting them on here. So, $3, as you can see, $9, $9. Then in my tens, I start with 11. And then I would have like 13. And this is 14, and this is 15, and this is 16, and this is 17, and this is 17. This is 18, and 18, and 19. This would actually round to 20, and that would be 20. So I keep on doing that for all of the specific values. So now I got to do that for all of them. I'm not going to list them all. You can probably do all the rounding, but hopefully your graph will match mine. So it goes 1, 3, 4, and I had a 5, a 6, a 7, 7, 8, 8, 9. The 20s have a lot. 3 20s, then 1, 2, 3, then 4, 5, 5, 6, 6, and then 4 8s, 1, 2, 3, 4. And then the 30s, 2, 5, 6, 9, 9. 1, 3, 4, 5, 5, 7, 9. 0, 3, 5, 9. 1, 0, 3, 6, 6, and then 93. Okay? So now, that's part A. Okay? Part B is going to ask you to do this graph over again. It says make another stem plot of the data by splitting the stems. Which of these plots show the shape of the distribution a little bit better? All right, so now we're going to split the stems, meaning, okay, I'm going to cut them basically in half. So I'm going to like have from 0 to 4 and 5 to 9 for each of these dollar amounts. Okay? So what happens here is going to be a little bit smaller. So I'm going to have 2 zeros, 2 1s, 2 2s, 2 3s, 2 4s, 2 5s, 2 6s, 2 7s, 2 8s, and luckily only 1 9, so I can fit it in. Okay? So now it goes like $3, and then the $9 are in the next one. So then I have like 1, 3, 4. So basically what I'm doing is I'm splitting these in, like, they're not necessarily really in half, but in half with respect to the dollar amounts. So now I'm talking 5, 6, 7, 7, 8, 8, 9. So then I can go 0, 0, 0, 1, 2, 3, 4. And then I get the 5, 5, 6, 6, 8, 8, 8, 8. And then 30, just 2. And then 5, 6, 9, 9. 1, 3, 4. And then 5, 5, 7, 9. 0, 3, 5, 9. 1, nothing. 0, nothing. 3, 6, 6, 3. So now, okay, now the question becomes, which of these plots, okay, shows the shape of the distribution better? Okay, they both are definitely skewed, and actually skewed to the right, okay, because the tail goes towards the higher scores. But what's nice about the split stems is you start to see little gaps in the data in which you don't necessarily see, okay, when it's not split stems. So I'm just going to kind of make note of that here. I'm going to try to squeeze it in kind of in maybe this area right here in the middle. Just note the split stems. Okay, graph shows the skewness gaps, and I even forgot to mention this, and potential outliers more clearly. They stand out a little bit more. Okay. So now, question C says, write a few sentences describing the amount of money spent by shoppers at the supermarket. Okay? So I'm going to talk about, kind of the shape, okay, the center, the spread, and potential outliers. Okay? So to talk all about those, this is what I at least have written down and I talk about here. So the first thing I say is the distribution. Notice I'm putting it in context. Distribution of the amount of money spent by shoppers is skewed to the right with a median. So then what I want to do is actually find this median, okay? So when I look at the median, okay, I get $27.86. So you might be wondering, how in the world, again, am I getting the median? I got, what, 50 data points, so it's going to be right in the middle. 1, 2, 3, so 3, 4, 5, 6, 7, 8, 9, 10, 20. So 21, 22, 23, 24, 25. Okay, so it's going to be right in between there. So what I did was I just added those two values up and divided by 2 and rounded it to the nearest penny. $27.86 for the median, and a range Again, max minus min, so I'll even do that for you. $93.34 minus $3.11 of $90.23. Okay? So I'm going to note also there are a few gaps. So from $62 to $69 and $71 to $82 and some potential outliers. I would say 80, the last two, 86 and 93, could be potential. All right, that ends page number 2.